So we're going to go ahead and get started. You guys still have your test over on AP Classroom. So we're going to have 2 additional free response questions for homework on top of that won't be due until Thursday, where your test is due Wednesday. So we'll be doing question 2 today, and then you'll have 1 and 3 for homework. So we'll be interpreting and evaluating derivatives and integrals of this function. So we've got a pot of t, and it's cooling according to this h of t function, where h is in degrees Celsius and t is any time in minutes, for the first 10 minutes. We've got a couple values for our degrees Celsius here in the table at different minutes after we pull a pot of tea out of the kettle. We want to use this to estimate the rate at which the temperature of the tea is changing at 3.5, so 3.5 minutes. What would I do to get an estimate for our rate of change?
The derive.
Okay, unfortunately we don't have a function, so I can't derive this directly, but how can I get an estimate for the derivative?
The average slope.
Average slope, okay. So if I want the slope at 3.5, what 2 points am I going to use?
To t equal to t 2 and 5.
2 and 5, perfect. Okay, so my average slope formula is going to be my derivative at 3.5 is roughly equal to my average slope at 5 and 2. H at 5 minus h of 2 over 5 minus 2. Okay, and then we'll plug in from the table. So h prime at 3.5 is roughly equal to h at 5, which is 52, minus h at 2 is 60, over 5 minus 2 is 3. So that's negative 8/3. What are my units?
Degrees Celsius per minute.
Perfect. Okay, for part B, Oliver, I want to know what 1 over 10 times the integral from 0 to 10 of h of t would mean in the context of this problem first. Okay, I think there's a problem with the microphone over with Oliver, maybe. See if I can unmute him from my end. Nope. Alright, so Junho, I'm going to stick to you then. So, I've got 1 over 10 times my integral from 0 to 10. What will it mean?
Oh. Mean.
So you said it'll be the mean? You're right, this is the average temperature. Over the 10-minute interval. So when we integrated from 0 to 10, we had Celsius times time. And then I divided by the 10 minutes that had passed, so I divided by time gives me Celsius again. So this is the average temperature in degrees Celsius over our 10-minute interval. The sum total of all temperatures divided by how much time has passed. Okay, then we need a trapezoidal sum with 4 subintervals that are indicated here to give our estimate for what this average temperature would be. So we've got 4 subintervals that are indicated by the table that we're going to use to build our trapezoids. Okay, how can we set up our first trapezoid?
66 plus 60.
Okay.
Times 2.
Okay, but I need an average here, so this
Oh.
is
Divided by 2.
divided by 2. Okay, plus
And 60 plus 52 over 2 times 3. 52 plus 44 over 2 times 4 plus 44 plus 43 over 2 times 1.
okay. So this is. I'm just gonna do this here. So my 2's will cancel here, so I've got 126 for the first part. We've got 60 plus 52 over 2 times 3 plus okay, so I've got 477.5 total. And then we can divide by 10 in order to get our average. I don't think I did that right. I'm going to try this one more time. Because I have this part. Plus 60 plus 52. There we go. Times 3. Okay. So I'm going to take all of this. And then multiply by one over 10. What are our units?
Degrees Celsius.
Degrees Celsius. Since we're looking at an average temperature. Okay. Now I've got the integral from 0 to 10 of h prime of t. What would the meaning be?
The rate of degrees of C is changing between 0 to 10.
You're really close. If I integrate this rate, I'm going to get the amount. So this is actually the change in degrees Celsius. So this is how much the temperature changed between minute 0 and minute 10. So if I integrate this, I'll end up with h of t from 0 to 10. And then I'll plug in our upper bound, and I'll subtract our lower bound. Right?
Yeah.
Okay, so that gives me 43 minus 66. Tells us how much our temperature changed in the first 10 minutes. So our temperature changed by negative 23 degrees Celsius. Alright, last one. At time t equals 0, we have biscuits with a temperature of 100 degrees that are removed from an oven. The temperature of the biscuits is modeled by a differentiable function, which is known to be b prime t is negative 13.84 e to the negative 0.173 t. Using the given models at time t equals 10, how much cooler are the biscuits than the tea? Okay, so I need to figure out what the temperature of our biscuit is at time 10.
Brendan?
Yes.
Oliver wants the C, like, you to explain the C again.
Oh. Okay. So C is how much our temperature has changed between minute 0 and minute 10. If you integrate from 0 to 10 of our rate, when we integrate the rate, we'll end up with the amount. So when you integrate h prime t, you'll end up with just ht. And then you'll plug in your upper bound and subtract your lower bounds. This is your temperature at 10 minutes minus your temperature at 0 minutes. Will tell you your total change in temperature. No problem. Okay, thanks, Juno. I can see the chat now. So, we were given b prime at t, and we were told what the start point was at 100 degrees Celsius. So how can we figure out what our b at 10 is?
100 plus integral 0 to 10 b prime of dt.
Perfect.
Right.
B prime of t dt. Okay, so we'll go ahead and calculate that really quick. So we are integrating negative 13.84 e to the negative 0.173x in terms of x from x equals 0 to x equals 10. That is a lot lower than what I was expecting. Oh, because we haven't added the 100. Okay, that's more reasonable. So Okay, these biscuits froze in 10 minutes, but... Okay, so B at 10 is 34.182. Okay, and the question was, how much cooler are the biscuits than the tea? So our tea is at minute 10, 43 degrees. So we could say H at 10 minus B at 10 is 43 minus 34.182. Or 8 something. 8.82. Alright, any questions on anything from question 2? So anything from this set?
No.
Okay. So we've got, again, questions 1 and 3 for homework from this free response set, but that won't be due until Thursday. You guys also have the quiz that's due tomorrow at midnight, which is up on AP Classroom. Okay, I'll see you guys on Thursday.
Oh, see you.
Bye.
Have a nice day.
You too.